In today's video, we are going to study arithmetic sequence. Before going further, subscribe this channel. What is arithmetic sequence? For this, we are considering an example 2, 5, 8, 11, and so on. There is a specific pattern. What is that pattern? Just think about it. We can view the pattern from one aspect as the difference between any pair of consecutive numbers. For example, we are taking this pair, then we are taking this pair, and then we are taking this pair. So in the first pair, if we are subtracting, and this is the first term, this one is the first term, and this one is the second term, this one is the third term, and this one is the fourth term. So in the first pair, we are subtracting the first term from the second term and we are getting 3. In the second pair, we are subtracting 5 from 8, that is, the second term is subtracted from the third term and we are getting 3. In the third pair, 8 and 11, we are subtracting 8 from 11 and we are getting 3. So the difference in each case is constant. This constant difference between the consecutive terms is known as common difference, and it is denoted by D. In this sequence, D is 3. So according to this definition, taking the example in mind, we can define arithmetic sequence as the arithmetic sequence is a sequence where the common difference D remains constant between any two consecutive terms. For example, we are having this sequence A1, A2, A3, A4, A5. So the first term, the second term, the third term, fourth term, fifth term, and so on is the sequence. This is the sequence. Then according to your definition, this D is constant, as in the example we have explained just now. This D was 3. So this is the constant number D. So if we subtract the first term from the second term, we are getting D. If we are subtracting the second term from the third term, we are getting again the same number D. And if we are subtracting the third term from the fourth term, we are getting D, and so on. If we subtract the fourth from the fifth term, we are again getting that number. Since this set of numbers is having a specific pattern, so this is a sequence. The number of this sequence are called terms. So our first term of this sequence, what we have done, the example, so the first term in that example is 2, and the second term is 5, and the third term is 8, and the fourth term is, this one is the fourth term. Fourth term is 11. Now we can view this sequence with another aspect. every next term of this sequence 2, 5, 8, 11 and so on. So every next term, for example, this is the first term and this one is the second term. So every next term in this sequence is coming by adding d with it. What was d? D was 3 in this example. So we can add 3 with the first term, this one, to get the second term. 2 plus 3 is 5, and then 3 is again added with this 5 and we are getting 8, and so on. If 3 is added with the third term, we are getting the fourth term. So every next term of every next consecutive number is obtained by adding the common difference d is equal to 3 to the previous term. So if we are taking, so this is the sequence, this one is the next term, because if we are going to in the same pattern we are going and we are adding 3 with the 11, so we will be getting 14. This is the next term. So this is the first term and we are adding 3 with it and we are getting the second term. Now this is the second term and we are adding 3 with it, which is d. So we are getting the third term. And this is the third term again. We are taking it and we are adding with it the common difference 3. And we are getting the fourth term. Similarly, this is the fourth term. And we are adding 3 with it and we are getting the fifth term. So what will be the next term? If we are taking 14, this is the fifth term and we are adding 3 with it and then we will be getting 17. So keeping in mind this pattern, what will be the definition of the arithmetic sequence? After this, we define the arithmetic sequence as an arithmetic sequence is a sequence in which every next term is obtained by adding a constant number, which is common difference, to its previous term. If this is the sequence, then according to the definition, the second term will be obtained by adding d with the first term. Then to obtain the third term, we are adding d with the second term. And similarly, to obtain fourth term, we are adding d with the third term. And to obtain the fifth term, we are adding d with the fourth term. So this is the case. If we are adding d with the first term, we are getting the second term. And to obtain the third term, we are adding d with the second term. And when we add d with the third term, we are getting the fourth term. And to obtain the fifth term, we will be adding d with the third term. So this is the case. This is second term and we are adding d with the first term. Then we are obtaining this. To obtain the third term, we are adding d with the second term and so on. In the previous example, d is 3. The common difference can be negative. Consider the example, this one. So just think about it. What is the number which we are adding with the first term to add the second term? That number is what? -2. So -2 is again adding with 1 and we are getting the third term. Similarly, -2 is added with the third term and we are getting the fourth term. Similarly, -2 is added with the fourth term to get the fifth term. This is the first term, this one is the second term, this one is the third term, and this one is the fourth term, this one is the fifth term, and so on. There is no doubt that this sequence is arithmetic sequence because the common difference over here is -2. If we add -2 with the first term, we are getting the second term. So A2 is obtained by adding D with the A1, and similar is the case over here. This is the first term and we are adding -2 with it and we are getting the second term. Now this is the second term and we are adding -2 with it and we are getting the third term. And this is the third term and we are adding -2 with it and we are getting the fourth term. This is the fourth term and we are adding -2 with it and we are getting the fifth term. So symbolically we can write A2 is equal to A1 plus D. Then A3 is equal to A2 plus D. A4 is equal to A3 plus D. A5 is 10 by A4 plus D. And this means that to get the second term, we are adding D with the first term. To get the third term, we are adding D with the second term. If we are adding D with the third term, we are getting fourth term. When we add D with the fourth term, we will be getting fifth term. In this way, we find the next term. What is that? That will be sixth term. So A6 will be equal to A5 plus D. What is A5? We have found -5. So -5, and what is D? D is -2. So what will be the answer? -7. -7 is the next term, which is sixth term. Now we are taking an example: 1 by 2, 1, 3 by 2, 2, 5 by 2, 3, This will be arithmetic sequence if the difference is constant. So compare it with, this is the first term, this one is the second term, and this one is the third term, and similarly this is the fourth term, and this is fifth term, and this one is sixth term. So A2 minus A1, what is this? 1 minus 1 by 2, which is 1 by 2. Now A3 minus A2, third term minus second term. This is the difference. Second term minus first term. This is second term, this is first term. And now third term minus second term. This is the third term and this is the second term. So 3 by 2 minus 1. What is the answer? 3 minus 2 is 1, so 1 by 2. Now the fourth term minus the third term. Fourth term minus third term. 2 minus 3 by 2. The answer is 1 by 2. So the difference is constant in each case. This means D is 1 by 2, and this given sequence is arithmetic sequence. Now taking another example, this is the first term, this one is the second term, third term, fourth term, fifth term, and sixth term. Now subtract first term from the second term. A2 minus A1. 15 minus 20. The answer is minus 5. Now third term minus second term. 10 minus 15, and the answer is minus 5. Now fourth term minus third term. 5 minus 10, and the answer is minus 5. This means the difference between two consecutive numbers is same in each case. So D is equal to minus 5, and this one is arithmetic sequence. Now we are taking another example. First term, this is second term, this one is third term, this one is fourth term, and this one is fifth term, and so on. This is sixth term. The difference between this pair is 2 pi by 3 minus pi by 3. What will be the answer? 2 pi minus pi, which is pi. Now take this pair and A3 minus A2. So pi minus 2 pi by 3. 3 pi minus 2 pi divided by 3 is equal to 3, and over here this. So you can see the difference is same. Now you can take this pair, also this pair and this pair, and we will be getting the same difference. So this is the common difference, which is pi by 3, and the given sequence is arithmetic sequence. Now take this one, this is the first term, second term, this one is third, and this is the fourth term. A2 minus A1, first is subtracted from the second, minus 2 square root 2 minus square root 2 minus 2 square root 2 minus multiply minus is plus. Square root 2 is taking common, it is taken common, so minus 2 and over here plus 1, and the answer is minus 1 and square root 2, which is minus square root 2. Now third term minus second term. This is the third term and this one is the second term. Minus 2 square root 2, because this is the minus of the A3 minus A2, and A2 is itself minus, so these two minus will be multiplied and we are getting plus over here. Square root 2 is taken common, minus 3 plus 2, and the answer is minus 1 square root 2. In each case the difference is coming same, so D is equal to minus square root 2, and the given sequence is arithmetic. With this I end the video, and we will meet inshallah in the next video. Subscribe this channel so that you get the next video on time. Thank you.